11.2 Reflections. This time in 11.2, we're going to talk about the transformation of reflecting. This is where we're going to create a mirror image. And when we reflect across a line of reflection. So here we can see that we have reflected figure A, but figure B has just been translated. It's just slit. So only A is a reflection. Okay, time for you to write in your notes. There's just a few fill in the blanks about the definition of a reflection. All right, we can reflect in the coordinate plane. And when we do that, we are going to use either the x-axis or the y-axis as our line of reflection. So if we want to reflect in the x-axis, that means we're going to, I like to say, flip it across the x-axis. Okay, so reflect in the x-axis is just like flipping it across the x-axis. The x-axis is going to be our line of reflection. And when we do that, our x values will remain the same. However, our y values will be the opposite of what they originally were. Now, the same is true when we reflect in the y-axis. We are flipping across the y-axis, and the y-axis is our line of reflection. We will have the same y values, but our x values will be the opposite. So let's do an example so that we can see that. So over here, we have a red triangle, and we are going to reflect it in the x-axis. Remember, that means we're going to flip it across the x-axis. The x-axis is our line of reflection. And when we said that, remember, our x values stay the same, but our y values change. So we can actually already pre-fill this out because we know our x values should stay the same, 1, 1, and 3, but our y values become the opposite, right? X equals same, y is opposite. So opposite of 1 is -1, opposite of 4 is -4, and opposite of 4 is also a -4. So if we were to plot that, our new points over here, we would say for A, actually our A tick mark is going to be at 1, -1. Okay, and then our B image is going to be at 1, -4. And then our C image is going to be at 3, -4. So our new triangle, or our reflected triangle, the image looks like that. All right, now if we want to reflect in the y, meaning we're going to flip across the y-axis, that means our y values stay the same, and our x values are going to become the opposite. So over here, again, we can kind of pre-fill this out, right? We know that our y values stay the same. Here's our y. It's 1, 4, and 4. Okay, but now the x's are opposite. So opposite of 1 is -1. Opposite of 1 is -1. Opposite of 3 is -3. So our new coordinates, ooh, that's a funny B, are shown here. Now we can plot it up here, and we say that our image A is at -1, 1. Our image of B is at -1, 4. And our C is at -3, 4. And then, our resulting image looks something like that. So Here we reflected across or in the x-axis. Here we reflected across or in the y-axis. Okay, time for you to write in your notes. There are just some things about reflecting in the coordinate plane. And now, time to do 2 practice problems. So for this first practice problem, we have to see, is this one a reflection? Is the image sliding? Or is it actually changing across a line of reflection? Okay, and number 2, this one, we're going to reflect the figure in the x-axis and we're going to reflect it in the y-axis. So first in the x-axis, and then we'll do a new problem of reflecting it in the y-axis. So I will do it for the x-axis really quick. Remember, when we reflect in the x-axis, our x values stay the same, right? So our x's stay the same, and our y values become opposite. So opposite of 2 is -2, opposite of 2 is -2, opposite of 0 is 0, and opposite of 0 is 0. Okay, so if we reflect this red figure in the x-axis, it will look like this. Remember, the x-axis is our line of reflection. So our new points, A is at -4, -2. And our B is at -2, -2, -2, -2. Our C is at here, and our D is at -2, 0, so same spot. So our new figure, our image looks like that. Okay, now I want you to take this red figure and reflect it across or in the y-axis. That means your y values will be the same and your x values will be the opposite. Okay, and that is it for 11.2.